Welcome to Grade 9's most exciting learning adventure. Discover every chapter through immersive visual learning. Watch until the end and understand every textbook concept with complete clarity. Like, comment, and subscribe for daily learning. Visit .com for new syllabus practice questions, revision materials, and exam success.
Table at constant velocity. If a table moves at a steady speed under a force F, its net force is 0. So friction must exactly equal F, opposing it. Constant velocity is your clue every time. Frictionless ball. On a frictionless surface, no force and velocity stays the same. Force along the motion and velocity increases. Force against the motion and velocity decreases. Just ask which way the net force points. Blocks P and Q. Block P has 5 newtons and 4 newtons opposing, leaving a net 1 newton. So P does feel a net force. Block Q moves at constant velocity, so its net force is 0. Read each situation carefully and don't get tricked. Snake boat. In the careless snake boat race, 95 row forward and 5 mistakenly row backward. The difference is 90 oarsmen times 200 newtons, giving 18,000 newtons driving the boat forward. Teamwork minus a few confused rowers. Net force and acceleration. The right choice. The object accelerates in the direction of the force, with acceleration proportional to that force. That's simply F equals ma in words. Reject any option that says opposite or inversely. Position time graphs. A curved position time graph means changing velocity. That's acceleration, which needs a net force. Straight lines mean steady or no motion, no net force. So pick the object whose graph bends. Sailor jumps. Yes! As the sailor jumps forward, he pushes the boat backward. Third law again. That's why you must be careful stepping off a small boat. It slips out from under your feet. Q8. High jump mat. The soft mat lets the athlete stop over a longer time, reducing acceleration and hence the force on the body. Same physics as the cricket catch and the airbag. Comfort and safety through more time. Q9. Cart collision. Trick question! By the third law, both carts push each other with equal force, loaded or empty. But the empty one, being lighter, will bounce off with greater acceleration. Equal force, unequal effect. Q10. Acceleration mass graph. If the force is constant, then A equals F over m gives a curved acceleration mass graph. But F itself stays fixed, so the force mass graph is just a flat horizontal line. Let the formula guide your pencil. Q11. Velocity time graph. First find acceleration from the slope of the velocity time graph, then multiply by the 10 kilogram mass. F equals ma. The graph hands you the acceleration, you supply the mass. Q12. Bullet stopping force. Use v squared equals u squared plus 2as to find the acceleration. It'll be negative, a stopping force. Then F equals ma with mass 0.05 kilograms. A big number will appear, showing just how hard the wood pushes back. Q13. Footballer contact time. First, convert 108 kilometers per hour to 30 meters per second. Then use F equals ma to get acceleration and v equals u plus at to find the time. Always convert units first. That's where marks are lost. Q14. Rough patch distance. Add the opposing forces. 7 plus 3 gives 10 newtons backward. Then A equals F over m, that is 10 over 2, giving 5 meters per second squared, slowing it. Use v squared equals u squared minus 2as with v equal to 0 to find the stopping distance. Combine forces first, then the kinematics. Q15. Tractor, harrow, trolley. Since F equals m1a1 and F equals m2a2, the combined acceleration is A equals F over the sum of m1 and m2. A little algebra gives the tidy result. 1 over a equals 1 over a1 plus 1 over a2. A lovely challenge for the sharp minds. Q16. Magnet and compass. The forces on the magnet and the tiny compass needle are equal, but the needle is very light, so it swings easily, while the heavy magnet barely stirs. Once again, equal force, unequal acceleration because of mass. Reducing friction. Friction is unavoidable wherever surfaces touch, so engineers work hard to reduce it, with oil and grease, smooth coatings, sleek shapes, and even magnetic levitation trains that float above the track. Clever ways to outsmart friction. Quest: friction and the wheel. Here's a project for the curious. Find out whether friction depends on how hard surfaces press, whether it's bigger before motion starts, and whether rolling beats sliding. Then make a colorful infographic, and you'll understand why the wheel changed human history. Quest: magnet cars. Try this at home. 2 toy cars with magnets facing, released so they push apart. Measure how far each travels, add weights, and plot distance against mass. You'll see the third law and F equals ma dancing together. Quest: rope around a post. Wrap a rope around a post, hang a heavy bucket, and feel how little effort holds it. Add one more turn and it's even easier. Friction grows amazingly fast with each turn, the very trick used to tie great ships to a pier. Quest: Newton's Principia. If history excites you, peek into Newton's own masterpiece, the Principia. Reading how he first framed these laws, in his own words, is a journey into the mind of a genius. Range of Newton's laws. How far do these 3 laws reach? From a rolling marble to orbiting planets and stars. They only need tweaking in extreme places, near black holes, near the speed of light, or inside atoms. For everyday life, Newton is all you need. Force. Definition. Revision time. A force is simply a push or a pull. It can start, stop, speed up, slow, turn, or reshape an object, and it always has both size and direction. That's your one-line definition. Newton. Unit. The unit of force is the Newton. 1 Newton gives 1 kilogram an acceleration of 1 meter per second squared. Say it in your sleep. Net force. Net force is the single force that could replace all the forces acting together. It's the final winner after all the adding and subtracting, and it alone decides the motion. Balanced forces. Balanced forces cancel out to a net of 0, so nothing changes. The object rests or keeps its steady motion quite undisturbed. Unbalanced forces. Unbalanced forces leave a leftover net force, and that is what changes motion. Remember, no unbalanced force, no change in motion. Friction. Definition. Friction is the contact force that opposes motion, or even the attempt to move, between 2 touching surfaces, our ever-present companion. Static versus kinetic friction. Concept. A subtle point. The friction that resists you before an object moves can differ from the friction while it's moving. That's why the first push of a heavy box is the hardest. Normal force. The normal force is the support push a surface gives, straight up, that is perpendicular, from itself. On a flat floor, it balances the weight, which is why things rest steadily. Weight. Weight is not mass, it's the force of gravity on an object, given by W equals mg. It's measured in newtons, and it changes if g changes, like on the moon. Mass versus weight. Don't confuse the two. Mass is how much matter you have, in kilograms, and never changes. Weight is a force, in newtons, and depends on gravity. Same mass on Earth and Moon, but different weight. Inertia. Inertia is an object's stubbornness, its tendency to keep doing what it's already doing. Heavier objects have more inertia. That's why a truck is harder to stop than a bicycle. Acceleration due to gravity, g, is the acceleration gravity gives to falling objects, about 9.8 meters per second squared, and it's the same for all masses. Feather or football, they'd fall together without air. First law, formula view. In symbols, the first law says, if net force is 0, then acceleration is 0. No net force means no acceleration, just rest or steady motion. Second law, formula view. The second law in symbols, F equals ma, or A equals F over m, with acceleration pointing the way the net force points. Your most used equation this year. Third law, formula view. The third law in symbols. The force A puts on B equals minus the force B puts on A. Equal size, opposite direction, different objects. The minus sign is doing the opposite work. System acceleration, formula. For connected objects moving together, just use A equals external force divided by total mass. Ignore the internal tugs. Only outside forces count. The shortcut that saves time. Momentum. Momentum is mass times velocity. P equals mv, a measure of how much motion something carries. A loaded truck has far more momentum than a cycle at the same speed. Momentum form of second law. The deeper second law. Net force equals how fast momentum changes. This version even handles cases where mass itself changes, like a rocket burning fuel. Powerful stuff for higher classes. Impulse idea. Here's the thread tying together the cricket catch, airbags, and landing mats. Stretch the time over which momentum changes and the force drops. More time, less force. A life-saving idea. Kinematic link. The exam secret. Use F equals ma to find acceleration, then feed it into your motion equations. V equals u plus at, and S equals ut plus 1/2 at squared. Force and motion working hand in hand. Big picture. And so we close the chapter. Forces cause every change in motion, and Newton's 3 laws let us explain and predict how everything moves, from a dropped pencil to a rocket to the moon. You now hold the keys to the moving universe. Well done, my dear students. Force. Force is a push or pull. It can start motion, stop motion, change speed, change direction, or change shape. Force is a vector, so always remember, it has both magnitude and direction. Its SI unit is the Newton. 1 Newton. 1 Newton is the force that gives a 1 kilogram object an acceleration of 1 meter per second squared. In formula form, 1 Newton equals 1 kilogram meter per second squared. This definition comes directly from Newton's second law, F equals ma. Net force. Net force is the single combined force after adding and subtracting all the forces acting on an object. If the net force is 0, motion does not change. If the net force is not 0, motion changes. Balanced and unbalanced forces. Balanced forces produce 0 net force, so there is no change in motion. Unbalanced forces produce a non-zero net force, so they change the object's motion. This is one of the most important ideas in the whole chapter. Friction. Friction is a contact force between surfaces. It acts opposite to the direction of motion, or opposite to the direction in which motion is being attempted. Friction can slow objects down, but it also helps us walk, run, grip, and stop safely. Newton's first law. An object at rest remains at rest, and an object in motion continues with constant velocity unless a net force acts on it. In formula idea, net force 0 means acceleration 0. This law is also called the law of inertia. Newton's second law. Newton's second law is F equals ma. It tells us that acceleration increases when force increases, and acceleration decreases when mass increases. Acceleration is always in the direction of the net force. Newton's third law. For every action, there is an equal and opposite reaction. The two forces are equal in magnitude and opposite in direction, but they act on different objects, so they do not cancel each other. In symbols, the force A on B equals minus the force B on A. Weight and gravity. Weight is the gravitational force on an object. W equals mg. Near the Earth's surface, g is about 9.8 meters per second squared. Mass is measured in kilograms, but weight is a force measured in newtons. Mass and weight are not the same. Equal force, unequal acceleration. Equal forces do not always produce equal accelerations. According to A equals F over m, the lighter object gets more acceleration, and the heavier object gets less acceleration. This explains the fruit earth example and the bullet gun recoil example. System of objects. When connected objects move together, treat them as one system. The acceleration is external force divided by total mass. Internal forces, like tension inside the system, cancel out and need not be counted for the whole system motion. Momentum and motion equations. Momentum is P equals mv. The deeper form of Newton's second law says net force is the rate of change of momentum. For numerical problems, connect F equals ma with the motion equations. V equals u plus at. S equals ut plus 1/2 at squared, and v squared equals u squared plus 2as.
Welcome to the ultimate grade 9 learning experience. Every chapter becomes simple when it is visual, interactive, and exciting. Watch and understand every textbook concept with complete confidence. Visit rehanstudio.com for new CBSE practice questions, revision support, and exam success. Congratulations, students. You have successfully completed Chapter 6, How Forces Affect Motion. Today, we learned how forces influence every movement around us, from everyday actions to powerful scientific discoveries. Keep observing, keep questioning, and keep exploring the facts. Until next time, and stay curious and keep learning. Goodbye, students.
Class 9 and 10 students. Don't worry, make science and social science easy with your CBSE teacher. Subscribe now, like, comment, and press the bell.